Hi and welcome to the first video lesson on indices. So by the end of this lesson you should be able to identify the base and index of a number, and you should be able to demonstrate the first law of indices. So what do I mean by base? What do I mean by index? So let's take a number, let's take a general number, let's say a, and we're raising this to a power of n. So we call this a the base and we call this n the index. And the word indices is the plural of index. So when we talk about indices, we're talking about indexes. So an example of this that you should be familiar with, we've got 5 squared. Now we say 5 is the base and we say the squared part, so the 2 is the index. And we know that we call this 5 squared, or we can also say this is 5 raised to the power of 2. And 5 squared is 5 times itself, so 5 times 5. So how about this then? 10 raised to the power of 6. Well, that's going to be 10 times itself another 5 times. So we're going to have 6 tens like this. How about this? 5 raised to the power of 1. Well, cast your mind back to when we said it was 5 squared, it was 5 times itself. So when you have a number raised to the power of 1, then that is just that number. That is going to be 5. Or we can rewrite 5 with a 1, so with an index of 1. But usually when it's an index of 1, we leave it. So let's take the first law of indices. So we say we've got 2 numbers of the same base, so let's just say a, and each of these have different indices. So when we're multiplying them, so we're multiplying numbers of the same base with different indices, then we're going to add the indices up. Let's take an example. Let's say we have 5 squared times 5 to the power of 3. We recognise that we've got the same base, and we're going to therefore add the indices up. And we get 5 raised to the power of 5. So that's 5 times itself another 4 times. Okay, let's take another example. 10 to the power of 4 times 10 to the power of 5. Same base, we've got 10, and we're going to add the indices up. So we get 10 to the power of 9. Okay, so hopefully you should be becoming a bit more familiar with this. 17 to the power of 6 times 17 to the power of 5. We've got the same base, which is 17. So what we're going to do, when we multiply these, we're going to add the indices up. 17 to the power of 11. Now let's try, rather than numbers, let's try some algebra. We've got x to the power of 3 times x to the power of 5. This time the base is x. We're multiplying them, so we're going to add the indices up. And we're going to have x to the power of 5. Alright, let's try this one. Y squared times y to the power of 5. Using the first law of indices, we're going to add the indices up, and we're going to get y to the power of 7. How about this one? We've got y times y squared. So what do we do here? Well, remember, when we have a number, and we don't have an index, we're going to assume it's 1. Because remember, when 5 raised to the power of 1 was itself, was 5, so then y raised to the power of 1 is y. So we can rewrite this as having y raised to the power of 1 here. And now we can add these up, and we get y to the power of 3. Now this is a tricky one. A lot of people can go wrong here. So we've got xy squared times xy squared. So you might be tempted to add the indices up here, and we've got x, y to the power of 4. Now if you did that, unfortunately you would be incorrect, because remember, we have the x, y squared, we need to add an indice with the x's. So we're going to assume that the indices on the x's is going to be 1. So we can rewrite this as x to the power of 1 times y squared times x to the power of 1 times y squared. And now we can see that we've got x to the power of 1 times x to the power of 1. So that's going to be x to the power of 1 plus 1, and the same with the y squared times y squared. So we've got y to the power of 2 plus 2. X to the power of 2 times y to the power of 4.